So, as you can see, this one is a little more messy. Let's go with the word messy. So we have 5 times the cube root of 12ab to the 4th times 3 times the cube root of 18a squared b squared. First thing you would do is I would put the two radicals together. It's just easier that way. So do 5 times 3, this inside, times this inside. Okay? So 5 times 3 gives you 15. Times the cube root. The root indexes don't change. Okay? They didn't change up here on the board, right? Square root stayed square root, so cube root and cube root stays a cube root. Okay? 12 times 18. Anybody? I think 216, good. A goes to a to the 3rd, b goes to b to the 6th. So it's 15 times the cube root of 216, a cubed, b to the 6th. Okay. Now, factor tree 216. Also going to shortcut this one because make sure we get through everything. It goes 36 and 6. And each 6 goes 6 and 6. Your index is 3. So you need 3 in a group. So it becomes 15 on the outside that's already there, times the 6 that you're bringing out. And then do your variables. Okay, so the cube root of a cubed is just a. Cube root of b to the 6. 6 divided by 3 is 2, so b squared. Last step, do 15 times 6, which gives you 90. 90 ab squared. Remember that your index doesn't change here. Okay. So 8 times 4 gives you 32. X to the 8th, y to the 4th. Factor tree 32. Okay, let's see. Here it goes, what, 16 and 2, is that right? And 16 goes 4 and 4, and each 4 goes 2 and 2. What's your index here? 4. Okay, so we need groups of 4. There's a group of 4. How many are left over? Just that one. Don't forget about him. Okay, so we got 6 times the 2's you're bringing out. 4th root, the 2 that's getting left inside. X is to the 8th, divide that by 4, you get 2. Y is to the 4th, divide that by 4, you get 1. Clean it up a little, 12. X squared y, 4th root, 2. Okay, you don't need to write that bottom part. Just make sure you write this part down here. Okay, like radical expressions, because now we're going to move into adding and subtracting them. In order to be considered like, okay, you need to have the same index and the same radicand. Okay? Remember, radicand means the stuff on the inside. So the inside has to be the same. That's always been true. Okay? That's always been true. The new part is the same index. And honestly, that's not going to really be an issue because you guys' indexes will be the same throughout the problem anyway. So it's not like you're going to get tripped up here. It's really here that you're going to get tripped up. Okay? So for example, this one here in green, the square root of 3b and 4 times the square root of 3b. Those are like because they have the index of 2 and they have the same radicand, 3b's, both times. This box here is unlike because even though it has the same radicand, you have different indexes. This one's got 2, this one's got 3. These are unlike because even though they have the same index, they have different radicands, 3b and 2b. Okay? So you need to have same index, which you always will, same radicand, which you may not. Okay, so you got to be careful there. All right, everybody good on the slide? Garcia, you good? Yeah. Okay. Okay, which moves us to a problem like this. Now, the hard part here is you look at that problem, you're like, all right, cool, none of them are alike, moving on. But you always have to check to see if you can what? You can simplify, factor tree them. Okay, so factor tree each one. Okay, so now we're kind of taking all the types, mixing them all together. All right, so 98 divided by 2 gives you 2 and hopefully 49, right? That's nice. And then 49 goes 7, 7. So that simplifies to 7 square root of 2 minus the 2 right here. 32 goes 16 and 2. The 16s go 4 and 4. Okay, so bring the 4s down here. So 2, that was there, times the new 4, square root of 2. Clean this one up, 2 times 4. To give you 8. And then when you combine these properly, you just do it like you would a variable, right, with your like terms there. Like, 7x minus 8x gives you negative x. Same thing here, 7 rad 2 minus 8 rad 2 gives you negative rad 2. And that's it. Okay, so you almost treat the radicals like variables. Okay, kind of coming back a little bit. Very good. So let's see what's. Oh, yeah, hold on. There you go. That one's for you. You'll also notice that I don't really change up the numbers a whole lot, so you kind of got to start seeing the same numbers over and over and start knowing the shortest way to factor tree them and stuff like that, like 12 especially, Alright, so let's see here. We had a 5 in the front of the first one, times the 2 we're bringing out, the square root of 3 that we're leaving behind, plus a 2 from the first part, times the 3 we're bringing out, square root of 3 that we're leaving behind, minus 8, no coefficient this time, square root of 2. So then we multiply where we can. 5 times 2 gives you 10. 10 square root of 3. 2 times 3 gives you 6. Square root of 3. Minus 8 square root of 2. And then combine like terms where you can. So we're going to go 10 plus 6 gives us 16. Square root of 3. We don't have another rad 2, but when we can combine it with this one, so just bring it on down. Minus 8 rad 2. The end. So you can conceivably go through a problem like this. Like I could give you 3 radicals up here, ask you to add, subtract them, have this one end up with a radicand of 3, this one end up with a radicand of 5, and this one end up with a radicand of 2, and you not be able to add or subtract any of them. Okay? That can happen. That's okay. Just make sure you don't accidentally combine them when you shouldn't. All right? Make sure they have the same radicand before you combine them properly. All right? Good so far. Cool. Next. Hey. Didn't seriously think I'd leave out you guys' favorite type of problem, did I? Joey, what do you think you do here? Yeah, FOIL! Good. Good. FOIL. Just make sure you FOIL with the radicals right. All right? And this one's a little, I mean, if you want to write these out and not do them in your head right away, I mean, that's up to you, because this is a little harder to keep track of everything than it would be normally. Or maybe to go one at a time, because you got to go outside times outside, inside times inside. Okay, so maybe take these one at a time instead of, how you normally FOIL, an x plus 2 and an x plus 3 or something like that. All right, so let's go here. 4 times 3 on the outsides for the first term gives you 12. 3 times 2 on the inside gives you 6. Okay, I'm going to use colors. All right, now here's a little something we haven't talked about yet. 4 rad 3 times a negative 6. Since 6 doesn't have a radical, it's not 0, it's just not there. So you just do negative 6 times 4 to give you negative 24, square root of 3. Okay. Good on that part. Let's go the next one then. 5 rad 2 times 3 rad 2. 5 times 3 gives you 15. 2 times 2 gives you the square root of 4. And then the last one, same thing as it was over here, just multiply the in fronts. 5 times negative 6, bless you, negative 30, square root of 2. Kind of looking like a roller coaster, didn't it? I didn't really write that straight, did I? Anywho, that's step 1. All right. Step 2 now on this, and this is where these get longer, is you have to go through and look through your problem, and if there's a radical you can simplify, you have to simplify it, right? We're going back to those 4 bullet points we wrote down, going back to that second one where it was really long with the explanation to it. That rule applies to every single problem. Okay, if you can simplify a radical, you must simplify it. Okay, so there's one radical up here we can simplify. Which one is it? No. Which square root up there can we simplify?
4.
Garcia?
4.
The 4, right? What's square root of 4? 2, right? Square root of 4 is 2. Okay? So if this is going to become 2 here, square root of 4 is 2, what's 2 times 15? 30. So the white is going to change to 30. But I'm going to write it all in black now. Okay, so 12 square root of 6 minus 24 square root of 3 plus 30 minus 30 square root of 2. Okay. And if there were like terms now that you have your radicals simplified, if there was like terms through here, you would combine those. But do we have any? We don't, so that's your answer. Okay? So all 4 terms. So here we go. 7 times 7 is 49. Square root of 4. Plus 7 rad 2 times 3 rad 3 gives you 21 rad 6. Minus 3 rad 3 times 7 rad 2 gives you, minus 21 rad 6. Minus 3 rad 3 times plus 3 rad 3 gives you a minus 9 rad 9. Okay? So, 2 steps you got to do here. Number 1, you got to clean up your perfect square roots, or any roots that simplify. So we got 2 of those. We got 4 and we got 9. Square root of 4 is 2. 49 times 2 gives you 98. Last one here, 9 times 3 gives you minus 27. Now go through and combine like terms. Okay? How many sets of like terms do we have on this guy? 2. Good catch. 2 sets, 4 terms, okay? 2 sets. First set, 98 minus 27. 71? Yes? Okay. Okay. Second set, 21 rad 6 minus 21 rad 6. What does that give us? 0 rad 6, which is? Oh, come on now. 0 rad 6, which is how many rad 6s? 0. And then 71 plus 0 is? 71. So our answer is 71. Okay. Done yet is divide. Okay. Now, when we do this divisions, or do these divisions, excuse me, we're going to keep it basic. Okay, and I mean it's about as basic as we can. We're not going anywhere near different. We're not doing new indices. Okay, so we're not going to do this with cube roots. We're not going to do this with fourth roots. We're just doing this with square roots. All right. So you really don't need this box. If you want to title it quotient property, that's cool. Rationalizing, that should be a word you've seen before, heard before. Denominators, obviously, hopefully we've heard that before. If not, we've been not paying attention to me for the past 6 months, and that makes me really worried if we've never heard the word denominator. All right. But anyway, so we're given a problem here with 3 square root of 5. So I'm going to go back a little bit. Go back speeding through the archives here. This is a fun video. Aha, here we go. These two right here. Remember when we wrote these down the other day? The radicand contains no fractions. No radicals appear in the denominator. Here, these two come into play. Okay? So we're going to do one like this first, and then the next one we'll do will be like this. Going back to our problem. Also thrilling video. Look, can't even edit this. There we go. 3 over the square root of 5. That's a problem, because you cannot have a radical in the denominator. So the process of getting it out of the denominator is what's called rationalizing it. Okay, you rationalize that denominator. Does anybody remember from yesteryears how you do that? Yes, Bueller. What, Ivo? Almost, not quite. Bueller says this. I know you guys didn't hear Bueller talk, but nobody does. You multiply top and bottom by the square root of 5. Okay. Top and bottom by the square root of 5. Why the square root of 5? Because it's what's down there. Okay. So this becomes a multiplication problem. So 3 times rad 5 gives you 3 square root of 5 over rad 5 times rad 5 becomes rad 25. Square root of 25 is what? 5. Answer. You rationalized. Congrats. Okay. You've successfully gotten the radical out of the denominator. And that's the goal, right? That's what the problem says. You can't have a radical in the denominator. We did something to get it out of the denominator. Good for us. Hey. All right. Now, that's one like you've seen before. This is older stuff. We're going to spice it up just a little bit with new stuff. Ready? Here we go. Yeah. Okay. Number 11 here has the square root, big square root of x to the 6 over y to the 7. Yeah. Okay, first step to this is that, and this isn't really stated anywhere as far as what we can do as far as rules, but you can do it this way, so just watch me do this part. Take it, And instead of writing it as one big square root, write it as two little ones. Okay? Write it as two little ones. Okay, now what's your index on those two right now? 2. Okay, so now your next step on the problem with the variables in it like this, if you can simplify those square roots, do so, because it's going to make your problem easier in the long run and easier to understand. Okay, so you can simplify both of those square roots right now. Okay, so the numerator first, x to the 6. Square root of that, do 6 divided by 2, what does it give you? 3, good. So you get x to the third up top. Alrighty, from yesterday's, right? Square root of y to the 7. Okay, we have 7 y's total. We need them in groups of 2. How many whole groups do we have? We got 3 whole groups. How many are left over? That was a terrible 3. 1 y left over. Okay? And the reason why I'm telling you guys to do it that way is because if this ends up simplifying to where you don't have a radical in the denominator, then you're done. Okay? So simplify them first to see if this actually works out so your radical's out of your denominator, and then you're done with your problem anyways. And you don't even have to do the rationalizing step. Unfortunately for us, it's not out of the radical. So now we got to rationalize. Multiply. What's going to get rid of the square root this time? Y. Good. Square root of y. Multiply by whatever's there. Okay. So we get on the top, we get x cubed, square root of y, over y to the third, square root of y squared. Square root of y squared is what? Y. Y times y cubed gives you y to the fourth. Good. Now, what's different about this problem? I'm making myself laugh now. What's different about this problem than the last two? The denominator is a... No. Last two are reds also. I'm looking for a B word. Binomials, good. Okay, this one's a binomial. Now, whenever you have a binomial in your denominator, you got to change your thinking. Because whatever you do, or what you do, if you want to do it like we did, I'm going to change the slides here. If you want to do it like this one or like this one here, you're not going to get rid of the radical. Okay? Now, I want you to look back through your notes. I want you to go back to this one right here. Okay, find it. Find it. Find it. The answer to this problem was what? 71. Okay, remember that? We took a radical binomial times a radical binomial, and we got a number that did not have a radical in it. Okay? And that's what you need to do. Now, what's the main difference that you see between these two binomials? What's the only difference you see between those two? One's positive, one's negative. Good. Okay, now, does this jog any memories? Oh, but it should. Anybody remember that? I know, it was like Christmas time. But what do you multiply that one by? Anybody remember? Stay with me, kids. Anybody remember?
Multiply by denominator.
Not the denominator, but what?
7.
7i what? Nope. This is going to be 7i minus 2. To get rid of that, you multiply by 7i. Nope. Plus 2. Good. Anybody remember what that was called? Started with a C. C-O-N. J-U. Come on. Conjugate. Good. Okay. For i's, it was called the complex conjugate because it was i's. Okay. Here you want just the conjugate. So since this one says rad 5 minus 1, we want a rad 5 plus 1, top and bottom. Okay? Rad 5 plus 1, top and bottom. The opposite sign. Same, everything stays the same, opposite sign. Which turns you into having a distribute problem on the top end and a FOIL on the bottom. So distribute on the top, you get 2, rad 5 plus 2. Distribute on the bottom, you end up with rad 25 plus rad 5 minus rad 5 minus 1. Okay, the top's going to stay the same, right? 2 rad 5 plus 2, no like terms there. Okay, I'm actually going to go 2 plus 2 rad 5 if that's okay with everybody. The denominator, square root of 25 is what? 5. 5 minus 1 gives you 4, good. Okay, and then rad 5 minus rad 5 gives you 0. All right, 0, so you're done there. Now, you have one last step. One last step. See how there's a 2 here, a 2 here, and a 4 here? All of those numbers are divisible by what? 2. So reduce them all by 2. So you get 1 plus rad 5 all over 2.